Hey, what's going on, everyone? Hope everyone is doing good in our Aspire community. Yeah, first of all, super grateful to have everyone on board. Me and Nathan have been working on this for a long time now, and to see almost 500 members at this point come in, enjoy our resources, and meet other like-minded people has been absolutely incredible. So thank you to everyone for that. And yeah, I guess this video is going to be a little bit about what science fair actually is. So a lot of you guys in this community are brand new to research. Like, you know absolutely nothing about it, which is totally fine. But I think I should just make a video that talks about kind of like the basics of science fair, what it is, what you actually do, like, just the absolute basics. Also, excuse my voice, I'm kind of sick right now, so just bear with me. All right, intro to science fair. Let's go. So, what is science fair? So science fair is basically a competition where you can design and carry out a research project and then present what you discovered from that research project, okay? So there's a few different ways to do this. There's a few different types of projects. And here's kind of the main four types, right? You have experimental, engineering, computational, and theoretical. Okay, so what does all of this mean? Experimental is basically like your typical science project, right? So you have some kind of research question. For example, do plants grow in more light or less light, right? And you're changing a variable and you're doing an experiment and you're seeing what changes, right? That's the absolute, like, the most like textbook definition of a science project. It's experimental, like experimental science project, right? So that's one way to do it, but that is like literally just the tip of the iceberg. Then we get into engineering projects, right? So engineering projects is where you start to get a little bit more flexible, right? Prototypes get involved. You can iterate on your design over and over again. You can start with one goal in mind and end up, solving a completely different goal, But the engineering design process is something that you kind of have to be familiar with, brainstorming, ideation, creating a prototype, refining your prototype, testing it, collecting data, all that kind of stuff is involved with an engineering project, right? Then you move into more computational stuff. So I'm not gonna lie, I'm not super familiar with this type of stuff, but for example, at ISEF, there is a lot of computational biology projects. It's actually an entire category where you're basically using a computer, and nowadays it's basically all like AI, ML research with some, CS-based exceptions, I guess. I don't really know a lot about this field, so forgive me. But you're basically using a computer to basically probably use some kind of data set and draw some meaningful conclusions from it. Lastly is theoretical. This is basically math, right? Math and physics and theory and like trying to make a project out of that, maybe creating a new formula or something like that. You're not really doing anything physically or on a computer. You're kind of doing something at the most like theoretical, conceptual level. And yeah, these are very technical categories, if that makes sense. So like math at ISEF is one of them. So that's kind of an overview of what projects are and kind of what science fair is, right? So now let's kind of get into ISEF, right? Because all of you guys are in this community for one reason. You want to get to ISEF, right? And absolutely, I don't blame you, right? ISEF is amazing. So how are you going to get there, right? There's a few different levels to science fair that you need to understand. The first up, we have a school fair, okay? And yeah, just a disclaimer, you may or may not have all of these, so don't panic if one of them is missing, right? But your school fair is basically just what it sounds like. If you go to a big school, you might actually have one of these where your school essentially hosts a science fair. People from your school can participate in it. Your judges are probably going to be like parents or teachers. And then the top, I don't know, like 10 or so projects will advance to districts or maybe even directly to states, right? So yeah, that's the first one. After that, you have the regional fair. So this probably involves multiple different schools. This could also be just like a certain district in your state or your country maybe. And yeah, it's just a bigger version of your school fair. And I guess the judges here might get a little bit more sophisticated. You might get some professors from a university, especially if the regional fair is hosted at a university. That was one thing that happened to me. Like, my regional fair was hosted at my local university, so a lot of our judges were professors. But yeah, still like pretty easy to qualify from. You just need to be pretty much. Sorry, I can't talk. You need to be locked. You need to be more locked in than everybody else to make it to ISEF from the regional fair, right? And if you don't make it to regional fair, Often how it works is that maybe the top one or two projects from regionals automatically qualify for ISEF, right? But let's say you're like the top, I don't know, you're like the runner up, right? Or maybe you're like top three or top five. Then you can qualify for the state fair, right? State fair is going to be the biggest fair before ISEF. It can be anywhere from like, I don't know, 50 if you're in like a smaller state, all the way up to like 500 if you're in like a big state like maybe California or New York, for example, right? And this is kind of like your Hail Mary for ISEF. You got to be really, really good to stand out here. And you need a really, really good project to qualify, right? So as you can kind of tell, it is a lot better if you're able to qualify from somewhere like regionals, or maybe even if you're from your school fair, if that's even possible. I don't even know. But yeah, state fair is a little bit harder to qualify from, but still absolutely possible. Nathan qualified from the Michigan fair, which had, I don't know, probably like a few hundred people in it. I could be wrong. Don't quote me on that. And I was able to place second, right? So it's totally possible to, win from a state fair and make it to ISEF, right? Finally, we have what you guys have all been waiting for, ISEF. Okay, what is ISEF? Why do I want to get here? How do I how does any of this work, right? So basically, ISEF is the biggest pre-college science fair in the entire world. Okay, so it's international. So people from all over the world with like the best science projects all over the world are going to come and compete here. All right, and you're basically going to be divvied up into roughly, I think it's 22 categories, spanning a wide, field, like a wide range of fields, right? Everything from material science to computational biology and like everything in between, right? So you're going to be someone who qualifies from like the state fair or the regional fair, and you're basically going to get placed into one of those categories, right? And most of the time, you're actually already going to know what that category is before you go and compete at ISEF, right? So now you might be asking like, okay, like now I'm at ISEF, what is the actual format of it like, right? And I can tell you it's actually really similar to all of these up here, right? And if you don't know how that works either, I'm going to tell you right now. So basically the way science fair judging works most of the time, at least for ISEF affiliated fairs, is you're here, you have your poster behind you, you're standing up, I'm sitting down, but you're standing up, you have your poster behind you, and you're talking one-on-one with the judge that's in front of you, right? And the judge is usually someone who is well-versed, at least kind of well-versed, in the field or area you're researching so that they can actually understand what the heck you're talking about, right? The level that they can understand your project increases as you move up the scale, right? If you're at your school fair, who are your judges going to be? Teachers, parents? Are they going to know about the intricacies of AI and ML? Probably not, right? Once you get to ISEF, suddenly all your judges are like professors, right? They're from prestigious universities. They know what they're talking about. Sometimes they've literally worked in the exact area of research that you did your project in, right? So you need to know your stuff, right? But I mean, you're gonna get there, don't worry about it. But that's basically the format. Most of the time you're one-on-one. There's two types of awards at ISEF: grand awards and special awards, okay? Grand awards are basically your first place, second place, third place, fourth place in each individual category. And then there's special awards. So these are basically awards given out by professional organizations. And usually they're like cash prizes or scholarships or maybe like free trips, something along those lines, to reward you for your work on your project. And usually your project has to align with some of their values in order for you to get their award, essentially, right? So that's kind of the gist on ISEF. Hopefully I covered enough there. I'm kind of just going off the dome right now, so forgive me. Okay, so now let's talk about what you actually do, right? Before any of this competing at science fair stuff, like day one, like ground zero, what am I doing, right? The first thing you need to do, and you've probably heard this a million times, is to come up with a question or problem, okay? And this is extremely, extremely important. This is why we've set up Aspire Plus and mentorship, so we can help people like optimize the heck out of this phase so that they have a good project and a good, question and problem that they're solving, is that just makes everything so much easier down the line, right? So what this means is you need to find a field of research or a niche or some kind of problem, right? You need to go pretty far into that problem or that niche, and find like a really niche like issue that you are able to solve with some kind of research project, right? Or maybe there's some like controversy about something and you want to try to clear that up through like an experimental type of project. Or maybe there's a prototype that's not cost effective at all and has a bunch of problems and it's like super expensive. Then maybe you can build a better prototype. It's all about building on existing research. I think one of the biggest misconceptions about science fair is that you have to have some crazy breakthrough project to win, and that's absolutely false. Okay, all you need is to improve upon existing research to the point where you have a decent amount of impact, and you're actually making a difference. That's literally all you have to do. The more impact, the better, obviously, but you don't need some kind of crazy impact research to win at ISEF at all. That's just not how it works. And yeah, after that, you need to design an experiment or build some kind of prototype to explore that problem or niche. This is going to be the bulk of your time, and it's going to be highly dependent on what you're doing specifically. Again, shameless self-plug, this is something that we're going to help you with in Aspire Plus as well, which is helping design your experiment and give you all the resources you need to complete it. But yeah, generally speaking, this is where a lot of the learning is going to happen. You're going to learn which tools are going to be useful for you. You're going to make mistakes. You're going to learn what stuff actually matters, what doesn't matter, time management, and all that good stuff, right? So this is kind of going to be like the meat and potatoes of your project. Then you're going to collect data. Data is the most important thing. It is like the lifeblood of your project. If you don't have data, no bueno. Okay, you need data and you need to analyze it in order to draw any meaningful conclusion. So you're going to have to do that. Then after that, you're going to draw conclusions, right? So you're going to be like, okay, I had this problem or I had this question, and then I did this project which aimed to solve it. What was I able to find, right? So this can mean like, okay, I made this prototype for this bionic arm, or this prosthetic arm, and it was 20% cheaper, and I added this much functionality to it, and this is how it's going to help people who are disabled. Great, or there's controversy about this chemical or this pesticide, so I did this project to create a new pesticide, and I tested it, and it's actually like 20% more effective and like 50% cheaper. Great, so that's the kind of conclusions you have to be drawing. This is where you try to weave in a lot of impact to make it sellable to a judge. And yeah, I think that the rest of that's pretty self-explanatory. Then comes the presentation, okay? This is what 2 out of 5 hours of our A to Z course is about, okay? The paper, or not the paper, but the board and your oral presentation are extremely important, okay? It is the only visual piece of your research that your judge is ever going to lay their eyes on, so it needs to be really good. And the oral presentation needs to do a good job of making you memorable, making you stand out, and also convey your passion for the area of research that you chose to do. Okay, presentation is absolutely probably one of the most important things ever. But I mean, yeah, ever after the actual research itself, obviously, right? But that being said, if you look at like the rubrics, right, for grading ISEF Grand Award, or like the ISEF Grand Award winning like rubrics, like what they actually use to judge your project, 50% of the points on there are from your presentation. They're not even from your research, So if you're able to sell a mid project really well, that is really good, okay? Because most of the time, your research is not going to go the way you want it to. You might lose some data here and there. Maybe some files get corrupted. You didn't get into the lab that you wanted to. You had to change a bunch of stuff about your project. Whatever, right? Just do the best you can, right? And then once you get to the point where you have to present your research, that's where you can go all out and you have the opportunity to sell your project and make it something that people actually want to care about, okay? So that is kind of the whole flow of what you actually need to do for science fair. So hopefully this whole thing made sense. Also, I know a lot of you guys are coming up with projects right now, so a little bit of sauce for you. This is our whole course outline, by the way. But This is one thing in our free course that I think you guys should pay attention to, right? What makes a winning project is literally just these 5 things right here: passion, impact, executableness, being thought-provoking, and being unique. And if you just go and like watch the video on this, you're gonna be so well prepared to create a winning project. Okay, so absolutely go ahead and check that out. Other than that, I don't have anything else for you guys. If you guys have questions for me or Nathan, feel free to DM us. Our DMs are always open. And yeah, thank you guys for joining our community, and we hope to talk to you guys soon. Peace.